Codility has this challenge labeled as respectable, and I would have to agree. Knowing exactly what they're asking you to solve is half the battle. Without that, success will be unattainable. But once you understand or can picture in your mind what they're looking for, it's not that bad. We just have to break it down piece by piece for easy digestion. In this video, I'll slow it down some as to take the time that might be needed with the hopes that it will be easy to understand. Feel free to pause the video when going over the clips of code to study them more carefully. First, let's take the word Maxcounters. Ignore the first word for the moment and concentrate on the second word, counters. In the example, they allow you 5 counters, so picture in your mind this. Each box represents a count, and for this challenge, the first box starts at 1 and continues to 5. I know it can be confusing as Python indices start at 0, but the counters really do start at 1. There is no need to code this particular part in any special way. What these 5 boxes do is keep a running tally of how many numbers are in the array as we perform our loop-throughs. In the array, we have these numbers here. See the very first number in the array? We have a 3, so we look at our counter and mark it with a 1 in the 3rd position. We are keeping a record of the amount of numbers in the array, or a count. We are going to loop through the array a certain number of times and tally up the counts. In our second loop through, or count, we traverse through the array, still keeping our count of the 3 when we hit our second number, 4. For this count, we now put a 1 in the 4th place. In our third traverse, we have another 4 in our array, so we increase our already count of 1 up to 2. We now have a count of 2 because we have counted 2 4s in a row so far in the array. Now this is where it gets sticky. In our 4th traverse through our array, we hit a wall with a 6. Why? Because our counters only go to 5. We have nowhere to put a count for 6. So what do? Well, we can't do anything, so this is where we reach our max. We've maxed out. Now, all of our counters are set to 2. It is at this point our counts essentially start over. Starting with all 2s, we then move on and traverse through a 5th time. At our 5th number, we have a 1, so we add that 1 to our counter for 1, which was set at 2 and now becomes 3. We do it again and hit another 4, so we increase our 4th counter up 1 and 2 now goes to 3. In our very last traverse, we have our 4th 4, so we add that to our 4th counter, moving 3 up to 4 for a final result of 3, 2, 2, 4, 2 as our solution answer. Well, that was the what. Now let's move on to the how. How you solve this took a little bit of assistance from my daughter, who is halfway through her 2nd year at university for a computer science degree. Even she agreed that it was a bit of a difficult challenge, but not so hard as it took her no more than 30 minutes to hash out a very simple piece of code. It does solve the problem, but fails to get 100% in performance. But that's okay. Starting very, very simply is going to be the launch pad for a gradual increase in performance until we reach 100%. For our simplest of codes, let's take a look at what's going on here. Take a moment and look this over. In a moment, when our next slide appears, I will break it down and show you line by line what's happening. But for now, let's look this over. Our counters are set here. It will return a list of 5 zeros. These are our counters. We set our max as max1 at 0 for now. For every element in A marked as X, we loop through. Our if statement tells it to only include elements in A that are more than or equal to 1, but no higher than n, which is 5. Because of this, we only have 6 loop-throughs, as it will not include the 6 because 6 is greater than 5. The next line counts up from 1, and the counters start counting up, as you will see shortly in our next slide. Our second if statement contains our max1 variable starting at 0. Our counter loop-through starts at 1. So for the next line below, it just reassigns our max1 to drop the 0 and start at 1. Again, you'll see what I mean on the next slide. Essentially, both of our if statements in the for loop will return the correct result. The else statement is only there as a technicality because it has to be there, even though it never gets utilized. If it did get utilized, it would return a list of 2, 2, 2, 2, 2, because our max1 equals 2, and a 2 in brackets times 5 will give us that result. Moving on, Our return statement, dropped below our for statement, just returns the counters from our two if statements. Our two if statements are sufficient to provide our desired solution. Okay, it's time for our second slide that breaks it all down. Hopefully you can read this. If you're viewing this video on your phone, you might be in trouble. Definitely get on your laptop or PC, as that is the best way to view what's being returned per line. And unfortunately, with so much information, it got a bit smushed. What I did was ran bits of code through a Jupyter notebook and pasted the results next to the lines and hashtagged them out so you can see what's happening. I suppose anyone can do this in their own IDE, however, I thought it would be worth making a video and walking through it. As a side note, I do highly suggest that any student to pick apart all kinds of examples of codes like this, print it out line by line to see what's happening under the hood, so to speak. As I talked about in the previous slide, here's a bird's eye view of the operations. I started it off with showing the counters x minus 1, returning 1, 1, 2, 3, 3, 4. And the next line showing the actual counters themselves, where you can see the incrementing of the counts. When I say our max value was 2, that 2 is the second loop through prior to hitting the 6. Do you see that? Our max value hits a stop at 2. Take a peek down at the second set of incrementing counters. Do you see how the value of 2 matches the counter of 2 above? That's why our max value is 2. It's our new start point for the rest of the array as it skips over the 6 and continues the count holding on to those numbers. Notice also how at 4, that is our solution answer. It will return the last loop through as our answer. So what went wrong here? Why did we only get a 55%? We didn't account for an array of only one element. We had one example using large numbers that returned a wrong answer and a few timeouts. But all this information becomes very useful because now we know with more accuracy what Codility is testing. This is one thing that's a little bit of a downside to the Codility challenges, as they don't reveal the test cases beforehand. Oh well. To account for the one element array, as seen here, we created a new variable of max2, created a new if statement for the max2, if it is greater, less, etc., etc., and we also tried to tackle the timing out errors by changing our counters command in the else statement to using the max function of I for I in counters instead of using a fixed operator, the asterisk, for multiplying n, all with the hopes that it would solve everything. Did it? Nope. But we improved with a 66%. We didn't get any wrong answers this time, just the wrong time complexity, O, n times n. Again, pause this slide and check out the code. On our third attempt, since we knew the time complexity was wrong, we went back to the fixed operator just to see what happens while keeping our second if statement to account for the one element array possibility. We ran it and got 88%. Exciting. We knew we were on the right track, but we were still timing out. So close, yet so far. For the right code to give us 100%, we knew we had to do some arranging. The counting command needed to drop down to here, and we needed to reverse the greater and lesser than symbols on the max values and make sure the max1 and max2 were reassigned to equal each other in the else statement. We had to put something there, again, technicality, and then we needed to go back to the I for I using the max function in counters before we could return it, only this time taking it out of the else statement and putting it in the for loop instead. And there it is, 100% performance with the correct time complexity of O, N plus M. Again, go through and watch the progression and pause to take a look at how it evolved. Trial and error, my friends. My challenge to you would be to take the 100% performance code, plug it into your own IDE, but take it out of the function call first. This makes it easier to print lines, at least in my opinion. Make sure you have your parameters for A and N typed out above for easy reference and just play around. Pick it apart, see what gets returned, or not. The reasoning behind this is that it's easy to learn in theory, but not so much in practice. So get practicing. Thank you for watching, and I hope this video was helpful to you. Daily videos throughout the week are coming out, so don't forget to subscribe.